lesson, we're going to begin learning about some of the theory underlying what acids and bases are and how they behave. We're going to look at how pH is calculated and where it comes from. Okay, what do you remember about acids and bases from previous science classes? Litmus paper changes color when you put it in an acid or base, right? Okay. What else do you remember about acids and bases? The scale is 0 to 14. Okay, it's actually below 0, but that's okay. We'll talk about that too. Okay. And what scale is that? pH scale. So pH is a measure of what? Acidity and basicity? Alkaline or base? Okay. Actually, alkaline's a slightly different term, but in the high school level, we pretty much consider alkalinity and basicity the same term, meaning the same thing. They're actually a slightly different term. So pH is a measure of how acidic something is. When you say, is that what you mean? Okay. Well, when we talk about how acidic something is, we're really talking about two different things. We're talking about strength of acids and concentration of acids. Two different things. Strength of acids and concentration of acids. So I can have a really strong acid, like hydrochloric acid, okay? But if I have it unconcentrated, I can drink it. Okay, but if it's too concentrated, wouldn't do that. Okay? What's the acid in your stomach? Hydrochloric acid. Okay? Now, battery acid, which is sulfuric acid, I wouldn't drink that even if it were not concentrated because that's kind of different stuff. Those sulfate ions can be a problem. But we won't go to that right now, okay? pH. What in the world is pH anyway? Does anybody know? What is pH? Has to do with ions. It sure does. It also has to do with molar concentration, which is what we're talking about in the previous unit, wasn't it? Okay? Let's define pH for you. The P, which is a lowercase p, and the H, which is a capital H, actually mean two different things. But you put them together and it gives you a definition for what pH is about. Okay? So the P in pH actually means negative logarithm. Negative logarithm. Now, logarithms, if you're using an older model calculator or a less expensive model calculator, your calculator's if you press the LOG button, you're always going to get a logarithm base 10. Those of you who are using the new TI Inspire calculators, every time you put in LOG, it asks you to tell what the base is. Okay? If you're taking Algebra 2, you should have already had some instruction about logarithms. If you are taking if you are taking Algebra 2 right now and you haven't gotten to logarithms, you might ask your math teacher about it because it would be helpful to you to hear the logarithm instruction now in math at the same time we're talking about it in chemistry. Okay? We're kind of near the end of the semester. I have to talk about this before I can talk about some other things, so I can't wait any later in the semester in the chemistry curriculum to talk about logarithms. Okay? So logarithms, we'll talk about what logarithms are in a minute, but if you're working with those TI Inspire calculators, you may want to, you could say base 10 on there. Okay? That's what LOG means on most calculators. All right. The H in pH actually means the molar concentration. Remember molar concentration? Moles of solute per liters of solution. We just did a bunch of calculations for that on the lab. Of protons. Why would we symbolize protons as H? Hydrogen. What is a hydrogen atom made of? One proton, one electron. If we take away the electron, we've got nothing but a proton. Okay, so what we're really talking about here is a hydrogen ion. Okay? So the H is hydrogen ion or protons. It means the same thing pretty much. Now this is using the term I've used before to tell you about acids and bases is the simplest of the acid-base definitions. This is based on what's called the Arrhenius definition of acids and bases. Okay, the Arrhenius definition of acids and bases. And we'll learn about 3 different definitions of acids and bases in Unit 9, but right now we're just going to stay with the simple one, okay? All right, so that's what a pH is. It's the negative logarithm of the molar concentration of protons, okay? What if I told you I wanted to know what the pOH is? What do you think that would mean? Negative logarithm of the molar concentration of hydroxide ions. Okay? P is negative logarithm. OH is hydroxide ions. And you're supposed to have memorized what the hydroxide ion is supposed to be. It's OH negative, right? Funny thing about the molar concentration of hydrogen ions or protons and the molar concentration of hydroxide ions. If the water temperature is about 20 degrees C, when you multiply this times this, you always get the same number. If the water temperature is at 20 degrees C, you multiply this times this, you always get the same number. Okay? So the molar concentration, so if we take the molar concentration of hydrogen ions and we multiply that times the molar concentration of hydroxide ions, we're always going to get the same number. 1.0 times 10 to the negative 14 molar squared. And that is always true so long as your temperature is at, or close to anyway, 20.0 degrees C. Okay. If you heat up the water, you actually get more hydroxide ions and more hydrogen ions, and so this number actually goes up and your pH goes up. Well, if I multiply one variable times another variable and I always get the same number, what do we call a number like this? A constant. Okay, we have a special symbol for this constant because it's so important. And we call this the auto-ionization constant for water. Capital K, capital W, but as a subscript, okay? So this is the term for this, or the name for this constant, is the auto-ionization constant for water. And the little W there, or the W, capital W that's subscripted, is for water, okay? What does auto mean? What's it, Does it by itself? The prefix means self, or by itself, or automatically, okay? Automatically ionization. Well, water, auto-ionization, how do we get ions out of water if it automatically ionizes? What ions are we going to make? Is that an ion? It's got to be positive or negative to be an ion. Ions have positive or negative charges, okay? Well, if I take a hydrogen ion off of there, what's left? Hydroxide ions, okay? We did that in the previous unit. Okay, it was a transition subject between units, what was it, 3 to 4, 4 to 5? I forget which 2 units it was. We talked about auto-ionization of water, but we didn't call it that. We just said that you can get hydrogen ions and hydroxide ions from water, okay? So if this is liquid water at about 22 degrees C, and we get hydrogen ions and hydroxide ions, okay, the concentration of the hydrogen ion is always going to be 1.0 times 10 to the negative 7 molar. The concentration of hydroxide ions is always going to be 1.0 times 10 to the negative 7 molar. And they're the same because every time I break up one of these, I get one of these and one of those. That makes sense? And so the moles of this have to equal the moles of this as long as all of these are coming from water. That makes sense? The number of hydrogen ions, if we're just breaking up water, auto-ionizing water, the number of hydrogen ions and the number of hydroxide ions have to be equal, but only as long as those ions are only coming from water. If I multiply this times this, what number do I get? If I multiply this times this, what number do I get? You don't even need a calculator for this. You get that number right there. So this, the molar concentration of hydrogen ions, times the molar concentration of hydroxide ions, gives you the value of the auto-ionization constant for water. The auto-ionization constant for water has a value of 1.0 times 10 to the negative 14 molar squared. Okay? And that number is equal to the molar concentration of hydrogen ions and the molar concentration of hydroxide ions. We have a special symbol for those. The special symbol for the molar concentration of hydrogen ions, molar concentration of protons, is symbolized as a bracket around that symbol. So whenever you see any chemical inside brackets, that means the molar concentration of what's inside. That makes sense? And so the molar concentration of this will be symbolized how? How would you symbolize the molar concentration? Brackets around it. Okay? And so we can write this then as Kw equals the molar concentration of hydrogen ions multiplied by the molar concentration of hydroxide ions. Okay? Now, in pure water, this is the molar concentration of hydrogen ions. What's the pH of that? Can you put that in your calculator? What's the pH of this concentration of hydrogen ions? Because that's what pH is, negative logarithm of hydrogen ions, or protons. Can you put it in your calculator and find the pH? Find the logarithm of this number right here, and then change the sign. What'd you get? 7. Now that makes sense because pure water has a pH of 7, doesn't it? All right. Trick question. Not really a trick question, but you don't need to do anything in your calculator to figure this out. What's the pOH of pure water? 7. Okay? Because it's the same number, right? All right. Now, a constant means that if this changes, this has to change to keep this number the same. A constant means that if this changes, this also has to change so this constant doesn't change. That's what a constant is. So if this goes up, this goes down to keep that the same. If the molar concentration 0.0042 hydroxide ions, OH negative, okay? That's molar hydroxide ions. I can calculate the molar concentration of protons using this relationship right here. If Kw equals this times this, and Kw is always 1.0 times 10 to the negative 14 molar squared, I've tried to find the protons, and I multiply that protons times the hydroxide ion concentration, and I have that. Okay? How do I isolate this and get it by itself? Divide both sides by 0.0042 molar. 0.0042 molar. All of this cancels out. One of the molars over on this side cancel out. And if you do the math, I suggest you practice this so you know how to do this. You'll get 2.4 times 10 to the negative 12 molar. That's the concentration of hydrogen ion in the solution.